Okay, ladies and gentlemen, 9.3, day one. Very, very straightforward, easy lesson. Everybody hates graphing, but I'm going to remind you that once we taught you how in your y equals a times x minus h quantity squared plus k, when we did our 149, remember what this did? This horizontally shifted my function opposite the sign, and this vertically shifted same as the sign. And what I'm going to do is we're going to approach this the exact same way. So here is my parent function for the square root of x. What I did here, I'm going to continue to do here. It works for all the functions. I'm going to do it down here for this one as well. It's just that one's the cubed root of x. Well, think about the parent function. Easiest number in the world to plug in, it's 0. Well, when I put 0 in, the square root of 0 is 0, and I plot my 0, 0. Next number I plug in, well, I'm trying to think of what's the next perfect square I can plug in there. Well, that would be 1. The square root of 1 is 1, so I'd go over 1 up 1. I definitely wouldn't want to put a 2 in there because I don't know what the square root of 2 is. I don't know what the square root of 3 is. I know about what they are. I want to know exactly what they are. So if I put a 4 in there, I know the square root of 4 is 2. So I'd go over 1, 2, 3, 4, and I'd go up 2. And there is my square root function. And remember, I can't put any negatives in here. That's why this is going on here. My domain is all real numbers x greater than or equal to 0 on this parent function because they start at 0 and they go to the right. My range is all real numbers y greater than or equal to 0 as well. Notice they're going pop to the positives because there's a positive in front of that guy. We're not talking about any of those vertical stretches and shrinks. That's all tomorrow. So, but what I am looking for is I'm looking for these 3 parent points in every graph, and it's going to be so easy. Now, this is a cube root. What's the easiest one to plug in? Well, notice I'm putting 0, 0 in the middle. I kind of squirreled in the middle here, 0, 0. And my first perfect cube is 1, and the cube root of 1 is 1, so I'll go 1 up 1. My next perfect cube, well, that would be 2 to the 3rd power, or 8, which means the cube root of 8, is 2, so then I'd go over 2, 4, 6, 8, and I would go up 2. Now, but because these are cubed roots or odd roots, we can put negative numbers in those. So the cube root of -1 is -1, so I go back and down. And then my next negative perfect cube would be -8. That's going to give me -2. I'm going to come over 8, down 2, and I can see my cube root function is kind of this S-looking thing, and my domain is all real numbers. It covers all the x's. And my range, it is also all real numbers. It climbs, it goes up really, really slow. It climbs up to the right super slow, and it climbs down to the left super slow. Okay, so now we're going to do what we call exploration. Usually, a lot of times we do this with the graphing calculators in class, but we're not going to do that. And what I'm going to do is I'm going to say, hey, let's make a t-chart here quick, x and y. And what I'm after finding what do I put in here that's going to output 0. That's what I want. So if I put -3 in here, -3 plus 3 is 0. The square root of 0 is 0. And I'm going to say -3, 0, 1, 2, 3. Now the next one I want is I want 1. What am I going to put in here that is going to give me 1 for y? Well, if I put -2 in for x, -2 plus 3, -2 plus 3, well, that gives me 1, and the square root of 1 is 1. So now watch, I'm going to go -2 up 1. And the next one I'm looking for, that was my parent point, right? And my other parent point I put in is, I won't complicate this, we put in a 4, we got a 2. So what we're really looking for is what number do I put underneath that root that's going to allow me to get a 2 out? Well, if a 2 comes out, I need a 4 underneath here. So if I put a 1 in, 1 plus 3 is 4, the square root of 4 is 2. So then I'd say over 1 up 2, and I would graph it. Okay? Now again, notice, I plotted that point, and that point. Okay? How I really like to graph these is I like to look and see, oh, this is underneath. Just like this was underneath, that h was in my squared. Okay? So, whoa, too far. This 3 is in the squared, so what that 3 is doing is it's horizontally shifting my function 3 units to the left. So what I do is I take my origin, and I move my origin over 1, 2, 3, and I said, hey, there's my x marks the spot. And then after I've dealt with that 3, in my mind, what I'm going to do is I'm going to look at this and then say, okay, now I'm graphing f of x equals the square root of x, and I'm graphing these points here, but from my x. And if I think of that in my mind, I'm 0, 0, over 1 up 1, over 4 up 2, connect them, boom, diggity, done. Now, the next one, I don't want to overcomplicate this, but check it out. There's a minus 4. What's that minus 4 going to do? That's going to shift it this way 4 units. So what I'm going to do is I'm going to move 1, 2, 3, 4, and that's going to be my x marks the spot. Okay? So there's my x marks the spot. And now that I dealt with that 4, what I want to do is I want to graph the cubed root of x, but I want to graph it from my blue x marks the spot. So then I would come over and I'd say xy. And if I put a 0 in, I get a 0 out. Now this is my origin. There's 0, 0. But I put a 1 in here it spits a 1 out. So I go over 1 up 1. I wouldn't put an 8 in because I can't get that. I can only go 1, 2, 3, 4, 5, 6, 7, 8. It's going to be too far down. So let's put a negative 1 in. I get a negative 1 out. So I go left and down. If I go negative 8, I'm going to get a negative 2 out. So I say 1, 2, 3, 4, 5, 6, 7, 8 from my x marks the spot. Negative 2. And I graphed it. And it's done. Okay? And again, here in number 3, this is the easiest way. What is that going to do? That's going to take it 2 units. It's going to go right 2. I'm going to say 1, 2. See that x marks the spot? Then I'm just looking at graphing this from that spot. And if I put a 0 in here, I get a 0 out. If I put a 1 in here, I get 1 out. If I put 4 in there, I get 1, 2, 3, 4. I get 2 out. And I just look like a genius because I can graph them really fast. Okay? And just, if I lost anybody on that, let me get rid of this and watch how cool it is. If I wanted to waste some time and say x, y, I'd say, well, let's see, if I put a 2 in there, well, that's going to give me the square root of 0, which is 0. Check it out, I'm at 2, 0. If I put a 3 in there, well, 3 minus 2 is 1. That gives me a square root of 1, which gives me 1. Well, that's why I'm over 3 up 1. If I put, what would I put in there to get a square root of 4 out? Well, I guess I'd have to go with a 6 now, wouldn't I? 6 minus 2 is 4. That's 2, so it'd be over 2, 4, 6, up 2. There they are. Okay? So, adding and subtracting under the radical symbol appears to move the graphs in which directions? Well, horizontal, opposite the sign. Okay? Before we go on, let me take a quick second with my quadratics. With my quadratics, I said y equaled a times x minus h quantity squared plus k, where my vertex was at hk, and then from that vertex, we would graph, we'd 149 it from there times our a value, right? Well, now we're just looking at something y equals a times the square root x minus h plus k, where it's not a vertex, but I'm going to start at hk. Check it out. I started at hk. And then I just graphed the square root of x from that hk. Same thing here. I started at hk. Okay? Now we're going to put together the next part, writing the equation for the function below. Check it out. This did not go vertical. It only went horizontal. So what is my function going to look like? My function is just going to look like, you can say f of x. I don't care if you call it, well, they really do want a function, but f of x equals the square root, because it was slid left 2 units, I'm going to say it's x plus 2. This one was slid right 3 units, so f of x is going to equal the square root of x minus 3, because it goes opposite the sign. Opposite the sign. Now here, now I'm making these off of these starting points. Okay? Down here on these cube roots, I still have starting points. It's going to be this little squiggly point where it goes up and where it goes down. That's my starting point. Check it out. It's 1, 2, 3, 4. It goes this way, negative 4 units. So f of x equals the cubed root of x plus 4, because it's the opposite to get me there. Over here, I went this way, right 3. So I'm at f of x equals the cubed root x minus 3. And that gets me to that point. Okay? No big deal. Well, now we're just going to look. Those are my horizontal transformations. My horizontals are always inside the function. Adding or subtracting inside the function moves it opposite the sign, left and right. Okay? Now when I come here, notice this 3. That 3 is not inside. That is going to change my y. It's not affecting my x, it's changing my y value in there. So again, if I looked at this, x, y, if I put a 0 in, well, I get the square root of 0 plus 3, I get 3, so I get 0, 3. If I put a 1 in here, the square root of 1 is 1 plus 3 takes me to 4, so I go over 1 up 4. If I put a 4 in there, the square root of 4 is 2 plus 3 is 5, so I go over 1, 2, 3, 4, 5. Or no, 1, 2, 3, 4, 1, 2, 3, 4, 5. And then I can see where I go. But again, this, because it's outside, remember, y equals a times x minus h quantity squared plus k. This, up and down, same as sign, right? So this is going to take my x marks the spot to there. And after I dealt with that 3, I'm graphing the square root of x from that spot. 0, 0, over 1 up 1, over 4 up 2. Done. And I don't need to worry about all that stuff, okay? Don't overcomplicate it. Keep it real easy. So what I want to do in the next one, again, quick. Look, give me my writing utensil. What I want to do is I want to move my starting point. 1, 2, 3, 4. Now from that x marks the spot, I want to graph the cubed root of x. Put in a 0, get out a 0. Now because this is a cubed root, I'm going to go over 1 up 1. Next perfect cube is over 1, 2, 3, 4, 5, 6, 7, 8 up 2. And because it's a cubed root, we can do negatives. Cubed root of negative 1 is negative 1. The cubed root of negative 8 is negative 2. So I get that little bugger. If I do it super fast, that's going to start me down 1, 2, 3, 4, 5. There's my X marks a spot. From that X marks a spot, I'm graphing that square root of X function. 0, 0, over 1, up 1, over 4, up 2. And I don't need to make X, Y tables. Okay? So, adding and subtracting outside the radical symbol appears to move the graph vertical, same as sine. Okay? Piece of cake. What we do here, notice these are not shifted left or right, these are just pushed up. That one went up 2. So this function, f of x, it's a root, it's a hook. So I know it's a square root x, it's not going left and right, it's only going up. So I add 2 outside my function. Number 2, my hook didn't move left or right. Because it didn't move left or right, there's nothing under the root with it, but it did slide down 2 units, my starting point, so that's why I went down. Okay, I'm looking at my starting points, and I'm placing them in there. If it's vertical, it's outside, same as the sine. I'm looking at my starting points for my cubed roots. My starting points, that's the middle of the squiggle on these guys. That was down 3. So that's f of x equals, it's a cubed root of x minus 3. This one is up 4. So that's f of x equals cubed root of x plus 4. Okay, horizontal and vertical transformations is all we are looking at today. This last slide, okay? What I'm going to do is have you guys pause it and do these 4 quick, and then we're done for today. Okay, we're back here. Now notice, again, what I'm concerned with is my starting points on these first 2, my starting points. I can see I went this way 1 unit, I went down 3 units. So f of x equals the square root of horizontal is opposite. So if I went negative, that meant I added 1 inside, and at vertical, if I went down, I subtracted outside. Okay? This one I went to the right 2 units, and I went up 4 units. So f of x equals the horizontal is inside opposite, outside same. Okay? And then these last 2, my cubes, I just ballpark it in that little middle of that squiggle. So when I'm looking at this one, it looks like I went left 4 and I went down 1. Well, that means f of x equals cubed root, it's inside opposite, outside same. This one went that way 3, up 2. F of x equals, it's a cubed root, inside opposite, outside same. Simple as that. And this will be adding on some vertical stretches and compressions and horizontal stretches and compressions tomorrow.